recent months have showcased remarkable breakthroughs enhancing the lives of paralysis sufferers. From digital aids aiding in walking to pioneering techniques involving spinal cord tissue implants, and even brain implants for regaining limb sensitivity. Today, a new advancement comes to light, offering renewed speech abilities for paralyzed patients. Two independent research teams have unveiled parallel studies on this front. Stanford researchers implanted electrodes into the brain of an ALS patient, targeting speech-related regions. This brain-computer interface, BCI, detects speech-related brain activity. Through 100 hours of AI-assisted training, the patient's thoughts were decoded into words and phrases by the machine.
Hey Ann, how's it going?
It is good to see you.
UC San Francisco and UC Berkeley collaboratively conducted pioneering research, implanting a sheet with 253 electrodes into an individual's brain. Similar to the previous study, the aim was to decipher speech intent patterns, associating specific brain signals with phonemes. Subsequently, these signals were translated into facial expressions and synthesized speech on a digital avatar. Stanford's study achieved a 9.1% error rate in a 50-word vocabulary, and 23.8% in a 125,000-word vocabulary. The BCI attained a speech rate of approximately 68 words per minute after 4 months. Meanwhile, the second study demonstrated an 8.2% error rate in a 119-word vocabulary, and 25% in a 1,024-word vocabulary, with a speech speed of 78 words per minute. While error rates for extensive vocabularies remain noticeable, this marks a substantial advancement over earlier endeavors. Edward Chong, county author of the UCSF study, stated that prevailing technology achieves 5 to 15 words per minute, while typical conversational speeds range between 150 and 250 words per minute. These studies serve as proofs of concept rather than finalized products. Further training is required, and researchers anticipate reduced algorithmic intensity in the future. Existing obstacles involve the need for patient assistance in using these intricate devices, reliant on device and computer connections. Electrode deterioration presents another concern, necessitating thorough testing of this technology. The studies primarily targeted individuals with some residual mobility and vocalization abilities. In advanced ALS cases, patients can solely communicate through minimal movements like blinking. Despite this, the research offers a hopeful stride towards alleviating the devastating impacts of this condition. Thanks for watching. Please consider subscribing to support independent news.